Anyway, give it up, please, for Rob Skillington.
Thanks, Brian. Yeah, so definitely was an interesting decision that we made. I try to convince myself every night that it was correct. So anyway, I just wanted to say thanks for coming. Today I'm going to talk to you about deep linking metrics and traces with OpenTelemetry, OpenMetrics, Prometheus, and M3. So a little bit about myself. I'm the CTO at a startup called Chronosphere. Previously, it was the M3 and M3DB technical lead at Uber. And these are open source metrics platforms that are compatible with Prometheus as a remote storage backend. And I'm an OpenMetrics contributor, which is a CNCF project. And I've been on that committee for 2 years now. So I wanted to talk to you about the state of monitoring a little bit, just to cover the context of logs, metrics, traces, the different signals that a lot of us rely on today for instrumentation and observability of our systems. Then I also wanted to talk to you today about combining logs, metrics, and traces and what that looks like today. And then I also, of course, wanted to talk to you about the topic that I submitted here, and this is the issue of deep linking metrics and traces and what that looks like. So I wanted to go through, just cover a little bit of context on some of these core signals that we use today for observability and monitoring. So logs essentially are used, have been used since the dawn of time. They've been made more useful, of course, with the advent of fast log search, whether that's using indexing or not. They're usually not structured much. Some have had more success here at structuring their logs than others. And that essentially comes down to, at your organization, what kind of logging frameworks you're using, what kind of metadata you attach, what kind of restrictions you have on your log messages. But at the end of the day, still a lot of us tend to have a significant amount of certain unstructured components to most log messages. So log output from a process can all, of course, be streamed to one place and collected somewhere. And then, of course, you can do your slicing and dicing on it. But fundamentally, there's usually some unstructuredness to parts of your logs. So now I want to talk to you a little bit about metrics. So metrics have also been around forever as well. They're usually a little bit more structured than logs. They basically, because of this, become faster to query and aggregate for specific queries that you know ahead of time. And with lots of log data, if you're frequently searching that and aggregating raw log messages and visualizing them, they tend to be a little bit slower at that because the very data structures that they are slower to aggregate at collection time and also slower to query and aggregate at query time. So, of course, the downside of this, though, is that they don't have per event detail, and you usually can use them for high-level analysis. However, it stops short being able to show you the things like the request and response details. So, looking a little bit about the popularity of metrics, Google Trends is never a good way to measure anything. But you can see here that at least for people trying to educate themselves on popular metrics formats, especially over the past decade, the last 2, 3, or 4 years has seen an acceleration of people interested in this topic. And I wanted to share some numbers here that were presented at PromCon just 2 weeks ago, actually, about the install base of Prometheus. So the number of Prometheus instances being used in Grafana has grown 4 to 5x year over year for the past 4 years. Last year in 2018, 54,000 people had a Prometheus data source installed in their Grafana. This year, 242,000, which is an incredibly huge amount of growth. So, talking a little bit about tracing, what that is, this is just one actually pretty poor and not very interesting trace, but this is an example of what tracing is. It's essentially the way of looking at event data broken down by the operations that your code paths are taking. So whether that's in a monolith architecture or a microservice architecture, it essentially has per operation data stitched together and related to each other visually with relevant timing information. So you can see on the wall clock, how long things are taking, executing certain requests and response flows. And then, of course, this is even a worse measure, perhaps, of popularity than the Google Trends search, but there's nothing like Grafana stats for any kind of tracing projects out there. So here we're just looking at the GitHub star numbers over time for the past 2 years of Jaeger, which is one of the most popular solutions out there for open source tracing. OpenZipkin is another, also very popular. And then I wanted to give you one perspective on these three signals. You could think of logs as essentially, when they are all streamed to one place, as a ton of different unique events, essentially. And when they're streamed to one place, they're all bundled together. And yes, you can aggregate and slice and dice in them using a log backend, but this is how at least they're structured internally and streamed to your backend. So a perspective on traces, these are submitted and basically assembled as linked events. So events that may have happened from different applications in a microservice architecture or different components in a monolith architecture, all stitched together. And how they're related together is intrinsically captured as part of a trace. And then, of course, metrics, is basically a report or a categorized view of the events coming out of applications. And so it's really like taking a spreadsheet and then creating a graph from the raw events that you capture in a spreadsheet. That's really what metrics has been, typically used for. And that's why, obviously, it's made in a format that can be easily aggregated at collection and query time. And it's much better for volumetric analysis because you take essentially samples at periods and times rather than just collecting every single thing. The drawback, of course, though, is that you don't have the event data anymore. So when you need to root cause an issue, you need to drill down further. You need to see maybe request response details between two microservices in your architecture. It doesn't have that. But again, there are many reasons why they're very useful. So I wanted to talk to you a little bit today now about what does combining logs, metrics, and traces today look like. So increasingly more observability platforms are providing at least 2 signals, perhaps all 3, for observability, for monitoring, and for instrumenting your systems. So here we see Prometheus, as well as Loki. This is basically all 2 projects that you can use in the Grafana UI to basically view metrics and logs, rather. And then if we talk a little bit about what the integration looks like with metrics and traces today, there usually there's a few products out there that do this, but they're all basically using some form of matching of metric metadata, basically like labels if we're talking about Prometheus, and a time window. So for instance, you might have like an error graph here with a count of error values over time, and then some of the metadata on these metrics basically can help describe which container those metrics came from. And then essentially, those are used to try and work out which trace may be representative of the metric that you're looking at. And if you have a lot of very good structure internally to how you collect metrics and traces, and you do a stellar job at basically keeping these systems configured very similarly in the tags and labels that they use, then you can basically narrow down the search space that you're looking for, and usually you'll find a representative trace some of the time, depending on your sampling strategy, of course. And we'll talk more about that in a minute. So this works for, again, if you're basically very meticulous in how you configure everything, if you sample at 100% and basically have made sure that this is going to work well. Unfortunately, that's not the real world. And a lot of the time, most of the useful graphs that you're looking at in a metric dashboard as well has some kind of aggregate function applied, which actually will drop the metadata, so the labels for Prometheus metrics, and the context then is basically lost. So if you have a sum of error counts across all of your containers, and you're viewing that in a dashboard, there's no way that you can really extract those labels out. They've been aggregated together to give you an aggregate view in the metrics dashboard. So it's a lot harder to go from a metric graph straight to a trace. And again, of course, it's only magical when you store every trace. Otherwise, you might just be jumping to the tracing UI, and there's just nothing there because the trace for that data point wasn't sampled. And one thing that's interesting, of course, here is that actually, Saman from Slack on Monday gave a talk at the Observability Practitioners Summit, where he mentioned, of course, that at Slack they basically only do 1% to 2% of sampling of traces in production. So, depending on your organization and depending on how volumetric things are for you with your backends, it just might not be possible to store 100% of traces. And then, we would really like the experience to be something of looking at an exact data point on a graph and being able to go from a request that comprised that data point exactly. So if you're looking at a 500 internal server error that happened on a specific HTTP route that has very low frequency traffic, then you want to be able to look at that exact issue. And you want to have high confidence there's going to be a trace there to be able to go directly from a graph to a trace. So that brings us to deep linking metrics and traces. So essentially, what deep linking metrics and traces are is it's a concept where we basically embed a tiny bit of metadata in the metric itself that we use as a foreign key into a trace that is captured as part of the request that the backend system is currently processing when it increments a metric counter or records a latency measurement in your metrics. And so I'm going to run through a demo of that right now. So first we're going to show a Jaeger example application, the Jaeger example application in open source. This has been modified to basically use the new OpenMetrics exposition format, which is a Prometheus extended metrics exposition format with support for exemplars. And then we're going to show you some of the changes we're trying to upstream to Grafana to leverage the deep links that we've made between metrics and traces. So first, this is our Jaeger demo application. It's basically generating a whole bunch of synthetic transactions, which are simulating requests, and basically generating metrics from that as well as traces. And then if we jump over basically to our metrics here in Grafana, which are coming back from M3 actually. So we're using Prometheus to scrape these metrics, and then Prometheus is remote writing these metrics to M3. With the exemplars attached all the way from the OpenMetrics exposition format to the backend. We can see here that trace IDs show up next to data points in our graphs now. And so if we just silo out the 500 internal server errors that are occurring in some of these simulated requests, we can see that we can just go directly from one of these errors in the graph to a representative trace. And then, if we want to try to drill down into this issue, say we've been paged, we've just looked at our graph, we've clicked on a trace, we can now basically see that this span here, so this part of the operation as part of the /dispatch HTTP request is failing. So basically, it comes into /dispatch, which then makes a self request to the same application actually internally called /customer. And then basically find nearest driver is another operation that's being called as part of this request. And essentially, this is the operation that's causing the error here. And we can see here that this is due to a Redis timeout after trying to basically look up some details for a user account. So that's kind of basically the crux of what we're doing here. We're just enabling the ability to go from a single jump from a metric dashboard and a single data point exactly directly to a trace. And so, I wanted to explain a little bit more about this, and then, of course, kind of step through piece by piece how we're achieving this. So this is essentially the picture of the demo and like what we're doing. So we have an application. We're using OpenTelemetry, which is a instrumentation SDK. Essentially, OpenTelemetry makes it a little bit easier to collect metrics, traces, logs, and export them to a variety of different supported backends. So, whether that's a vendor, whether that's Prometheus, and whether that's Jaeger for traces, it doesn't really matter. You write the code once, and it exports to these different formats and backends. And so I wanted to dive in a little bit more into OpenTelemetry. So you can see basically here, this is an example of us using a gauge to track with a metric the number of jobs queued inside a server. So maybe you're sending out some emails or some other long-running tasks. And essentially here, you're also capturing spans to basically try to model the operations that are going on internally. So here, before we enqueue a job, we create a span to capture the job enqueue operation we're doing. And then, highlighting here the context that we're passing to the metric gauge when we set the current value of the jobs currently enqueued. That context, because that context is associated with that job enqueue operation, and that job enqueue operation is part of a trace, which has a trace ID, internally, OpenTelemetry is able to provide the metrics exposition format, which, such as OpenMetrics, which is Prometheus-based, the trace ID that this request was part of. So looking a little bit more at OpenMetrics, so this is the project. This is basically the Prometheus exposition format with extensions for exemplars and a whole bunch of other things. But that's a whole different talk, and I could talk ad infinitum about OpenMetrics. But essentially, it is now here in this demo basically propagating the trace ID correlated to the metrics that we captured. And this is a little bit about what OpenMetrics looks like on the wire. If you're familiar with the Prometheus exposition format, it may look very familiar. And basically, exemplars here are captured as a trailing comment next to a metric value. So essentially here we have some counters for HTTP request total, broken down by different status codes, and we also have some histogram values that we're also tracking. And each one of these has a corresponding trace ID. So basically, each one of these is at least one trace associated with that, that metric and that label set. So, and, putting it all together, when asking, how does this look like from end to end, essentially we are collecting the metrics and traces together. Because we do that, we are able to associate the trace ID to the metrics that gets basically transmitted to Prometheus using the OpenMetrics exposition format. And then Prometheus is essentially taking that exemplar, storing it in memory, and then it can then, of course, send it on to a backend. And then in this example, we're going to use, we are using M3DB here. M3DB is essentially an open source project, as I said, which came out of Uber. It was basically the core backend for the metrics platform at Uber, and is a Prometheus remote storage compatible backend. And it kind of housed more than 10 billion metrics at Uber, and ran across thousands of machines, comprising 2 to 3% of the compute footprint at Uber. So we used it at Uber for a global view of metrics data across regions. So diving in a little bit more to how Prometheus and M3 work together here, essentially Prometheus scrapes the exemplar, and as I mentioned, it'll keep it locally in memory, so you can kind of have that same experience that you saw on the dashboard just using Prometheus alone. And then in this demo, we're writing it to M3, which actually stores it in durable storage right next to your metric for whatever retention period you've configured M3 or M3 DB to store metrics for. So here you can see like a single stored value bit packed in the M3DB column format. And basically timestamp has, the first part of this component is the timestamp delta bits. The second part is the float64 value delta XOR bits. And then the third part is the exemplar bits. Now, a trace ID has relatively high entropy because it's usually based on a UUID, and UUIDs are providing you with high entropy, so there's no collisions. However, there are certain things you can do to try and compress this a little bit better than you might think. But that's a topic for another day. So when querying the data, M3 query makes sure to keep at least one representative exemplar per data point as part of the result, even after applying a sum or a histogram quantile function or any kind of other aggregation function. And it does this by basically every time you fold one of your data points together when you're doing an aggregate function, by basically just making sure that it keeps at least one of the associated trace IDs to the data points for that given timestamp and step size that you're currently calculating. So there's still one big caveat here, though. With this approach, we're still relying on traces existing in our tracing backend that we picked to correlate to our metric data point. So, when you're talking about applications or services, maybe not in a single container, but across many containers that process thousands or if not hundreds of thousands of requests in a given time window, especially if you're basically collecting data points at a 60-second resolution, but you can also obviously step that down to lower as well. This is relatively efficient because you have, on the metrics backend side, because you have a single data point stored with a single trace ID correlated to that data point. However, on the tracing backend side, you need to store basically thousands of traces here to guarantee that the trace that you correlated with the metric data point is going to be available when you click that trace ID in the graph, and you want to jump from the metric data point to the trace in the tracing system, because the tracing system doesn't have any idea of which trace ID you ended up picking. Wouldn't it be nice if the trace ID we picked as an exemplar for any given metric data point could be guaranteed to be stored in our tracing backend? So it turns out that using metrics aggregation is actually it has a lot of upsides basically for keeping traces that are interesting to a human. Firstly, it aggregates them across time. So basically, it's going to make sure that you consistently get a certain amount of traces at a useful time interval that's meaningful to you. Metric tags are also great at capturing unique combinations of events. So you already break up your metrics by error, success, error status code, the latency bucket that a data point is falling into. A request is falling into for a representative data point. This also ensures basically unique combinations of types of traces, because a lot of the sampling today, head-based sampling and adaptive sampling and tracing, is all based on as soon as you start a trace, the incoming data of the request. So basically, you can try to categorize and take one of each type, but that type can only be calculated using information at the beginning of a trace. So, what HTTP route or what service it's at, but it can't use things like how long that request took or if that request served an error. And the reason it can't is because it has to decide whether it's going to sample it at the beginning of the trace. So, putting it all together again, basically using metric aggregation can allow you to select the interesting traces across tags and dimensions that are meaningful to you in your labels for your metrics. So basically in this model, we wait until metrics are aggregated, and then we basically call out to a cache that is holding all traces that we're sampling. And for this model to work, you really need 100% sampling at the application layer, and then holding those 100% of traces in a cache. You can spread that across like a typical well-known cache like Redis or Memcached or something. And essentially, once metrics have been aggregated and collected, you basically choose exactly the trace IDs that you chose to correlate to your data points out of that cache and make sure that they're stored in your tracing backend. And it's worth mentioning here, of course, that you can, of course, have that in addition to your default 1% to 2% sampling strategy using head-based sampling or adaptive sampling. And so, I wanted to kind of give, obviously, a update of the status of this project. This is the current end-to-end demo that I ran today. However, that demo relies on a lot of upstream changes, some of which have been merged, some of which haven't, some of which also require discussion with the community and developers of Prometheus and of OpenTelemetry. So basically, the demo is also currently using Jaeger to export the traces and the OpenMetrics exposition format itself, due to basically our efforts trying to use the current head development checkout of OpenTelemetry, and not quite being able to make that work with our current demo. And I also wanted to mention that the Prometheus client library requires significant changes, and there needs to be an in-depth discussion with the maintainers, which they're obviously, we're kind of in talks about that, on how to make this a clean kind of change. So a shout out, like as I mentioned, to everyone who's been basically the Prometheus contributors, a few people like Grafana, helping discuss, review, and make some progress with us on this. And if you want to download the slides at the end of the talk, which I wasn't able to do right before the talk, so I apologize about that. But basically here are those links. You can download the slides and kind of like splunk around the different projects. And with that, I just wanted to say thank you for being here. Thanks for coming. And come say hi at our booth. I work for Chronosphere, and we have a booth in the sponsor booth. But yeah, thanks so much for coming and seeing the talk.
If you have a question, please raise your hand. I'll bring the mic. Also, while I'm finding questions, please take a moment to open up the Sked app and rate the session. We really need the feedback to make a better KubeCon next time.
Hi, my question is, this traces and the metrics, do you usually do it for applications for traces for inside information, or it's possible to embed it? I mean, do you know cases that the traces could be embedded for applications that ship to customers?
That's a good question. I've definitely worked at organizations where instrumentation coming from a mobile phone application is transmitted to the backend. I'm not sure if that's exactly kind of what you're mentioning, but basically, there is obviously the ability to link client-side traces with server-side traces. It does require a pretty robust tracing pipeline where your mobile client knows how to send up relevant metadata that it captured internally, so that it can be linked to the tracing data on the server backend side. And a lot of companies, everyone I've seen, they're all doing that a little bit differently. So unless they're using some vendor solution that's out of the box, but even then, I don't know of any vendor solution that's doing tracing that works both in the mobile application and the backend and joins the traces together. I just haven't seen that out there generally available.
Hi, I have a question. So you're just taking exemplars, right, in that particular period, right? So I guess the question, does it explode like the cardinality, like within Prometheus, or?
Yeah, great question. So that's what's really nice about this implementation is that you're not actually adding a label to the metric itself, which generates, would generate a new time series in the backend. This is actually taking the existing time series that already has an existing set of labels, and right next to the float64 value that you capture and the timestamp that you capture for that data point, you're packing a few extra, well, a lot of extra bits actually if you're recording a UUID to record the data point. So it doesn't change the cardinality of your metrics whatsoever, but it does make the bytes per sample go up by a significant amount depending on what you're using for trace IDs. Now, that would be scary if every single metric had a trace ID correlated to it. But if you really, there's definitely ways to basically configure this so that only certain metrics, maybe your RPC metrics, maybe your like front-end, HTTP, gRPC metrics, actually get this annotations on the trace IDs, of trace IDs to them, which means like, basically only a few % of your overall metrics ever get an exemplar associated with it. And that helps control the overall extra space required for using exemplars that we've found. But thankfully, it doesn't touch the cardinality at all as well, no matter how you configure it.
Hey, can you talk more about how you're able to find the unique combinations of metrics? Like, where is this logic handled or stored?
A combination of metrics? Yeah, so that's a great question as well. If you basically typically use Prometheus out of the box, you are kind of guaranteed that as long as you have like a container label. So basically it's going to subdivide all your metrics by the process that actually gathered them because of the label on the container. Basically with M3 it is a little bit different in that it has an aggregation tier that sits in front of that. If you're using just default M3, that actually is an embedded process that happens in a coordinator, and it's called the M3 coordinator that sits as a sidecar next to your Prometheus instance. But if you're not running a sidecar model, then you have a central replicated M3 aggregator server. The metrics all flow through that. And you basically configure rules, which look which basically are recording rules in Prometheus land to like kind of mash metrics together to reduce the cardinality for faster queries. So it's kind of that process of that's what determines of like which labels end up in your metrics eventually.
All right, thank you.
I have another question about the database. Is this database good for storing Kubernetes events and then match them to, not with trace log, but with metrics, maybe with trace logs as well? Because events, they usually stored for 1 hour and they need to be stored as well.
Just to clarify, you're asking, can things like M3DB be used for storing events? Is that correct? Yeah, that's a good question. So, I mean, I would say that it's definitely was not designed at first to do that, and that I think that more vanilla column stores are probably better at doing it. M3DB does have support for storing data, like data that's encoded in protobuf. So you can store like native protobuf messages over time for a time series. But I wouldn't really advise it, and there's not much, if any, documentation on how to do that with M3DB. So yeah, I personally would just use a typical, like some other column store for that, like, I don't know, ClickHouse or, there's plenty of stuff out there.
Hello. I'm not sure I understood what the status in Prometheus about exemplar addition to the metrics.
Yeah, great question. So we merged one PR now that the rest are all still open and or in discussion. The PR that we merged was adding the support for parsing the exemplars in the OpenMetrics exposition format. However, Prometheus right now, even if using a client library that supports that exposition format, of which right now is only the Python client library, Prometheus will do nothing with that. It basically throws it away. There is, like as in that demo, there's a link to like basically the modified Prometheus that we're using that we're trying to upstream that basically puts that in a memory storage, and then allows that memory storage to be accessed as you're writing remote values to a remote storage. But that's a very controversial PR that I think will go back and forth for a little while. Honestly, Callum at Grafana is kind of actually carving out that piece of work to work on himself. And so we're going to probably let Callum take that from there. But we'll just see what happens.
I think this is going to be the last question, unless anyone's really desperate. So,
Hey, amazing idea to connect traces and metrics. As you were talking, I was thinking whether you all have thought about the other way around. So instead of having a foreign key within metrics and connecting that to traces, let's say having a notion of a foreign key within the trace as baggage, and then using that to connect to metrics. So I'm imagining all the labels associated with the metrics as tags into the traces, and then tail sampling based on unique combination of those and keeping every unique trace.
That's a very interesting idea, yeah. I definitely, well, I'll be honest, no, I haven't thought about that. I think what's interesting is when you introduce aggregations to this, a lot of this stuff becomes possible because you're basically holding a whole lot of state in memory as data is flowing through the system. Problem with that, that's a relatively stateful system that as you scale up, is obviously yet another distributed system that you're running alongside your database. It's definitely not a small feat to do. You could do that because you're using the metrics aggregation to choose the trace ID, so you have the relevant information of it. But yeah, I haven't thought about how you would store that or how that efficiency model would look like. That's a very interesting idea, yeah.
okay, remember the feedback on the Sked app, and thank you very much, Rob.
Right. Thank you.